Hello, everybody. Welcome to the CUDAN Open Lab Seminar on April 12th, 2021. So today it's my greatest pleasure to welcome Björn Ommer, who is a well-known figure in the area of computer vision, particularly in the combination with art history. And so Björn, very welcome. You have been in Heidelberg for a very long time. I think the first time we met in person was in a pizzeria somewhere in Heidelberg.
That's true.
That's a very long time ago. Oh my God, is it 12 years?
When you were still in Zurich, right?
Yeah, exactly.
You were still in Zurich.
No, I was in Boston actually at that point.
Okay.
And so, okay, so ever since, even at that time, you did computer vision and art history, which many people can claim they do since 5 years, but you do it for 12 or longer, 15 years. And something very exciting was announced a couple of weeks ago. You're moving to my birth city of Munich, where you will be a professor, not of computer vision, but of artificial intelligence and cultural analytics, which is quite interesting because it carries this word cultural analytics, which there is a growing number of high-profile universities, such as CUDAN University, doing it. The other thing is this happens within the so-called digital initiative of the state of Bavaria, which is also quite interesting. So like Estonia, Bavaria has this sort of focus on the digital. And in this particular case, one part of the initiative is hiring a lot of faculty in the area. And one of the premises, I think, for everybody in the audience is that it seems there is a strong combination of a strong traditional art history program that will be complemented by what you are doing, but you do much, much more things, and you do computer vision more general. And one of the things we can learn today is not only what can art history or cultural research dealing with visual images learn from computer vision, but also going in the other direction, what can be our contribution as maybe qualitative practitioners, quantitative practitioners, people who apply machine learning, or people who engage in the development of machine learning. How can this go in both directions in essence? And so your talk is titled Digital Humanities, Next Frontiers Beyond Digitization. That's exactly also what sort of the mission of this CUDAN era chair is. The question is, once we have digitized all this stuff, what now, right? What do we do then? And so we're very, very curious regarding the answers you have and your plans regarding this. There is plenty of people joining from outside of Estonia even, including from Munich. So that is also an opportunity. Maybe before you start, I should explain how this works here. What we do in the CUDAN Open Lab Seminar is basically forefronting discussion. And so the idea is that there is typically 30 to 40 minutes talk, and then there is 80 minutes discussion. This can be interspersed, so you can, take questions whenever you want. You can talk for 2 hours, then there's no discussion, of course. But it can be as open as possible. We had even experiments where sort of like the speaker took questions and then the whole talk derailed into a really, really interesting discussion. So basically it's whatever your preference is, we follow you on the journey into the intellectual ski area, wherever you take us. Stage is yours.
Thanks, Max. Can you hear me all right? Perfect. Thanks for the kind words and for the kind introduction. Yes, I've been for more than 10 years now in Heidelberg, and ever since been computer scientist by training, also in physics and in other disciplines as well. And in particular, here in Heidelberg, already had a dual affiliation, and the same thing will continue in Munich. So I'm not giving up one side for another or whatever else, because I truly believe that if artificial intelligence and machine learning, to be more precise, is eventually living up to its promise to come up with intelligent information processing, that is something that will not be hidden in some corner of our scientific world, but eventually will show in all sorts of applications that we'll have, and with that in all sorts of sciences that we have. And in particular, and that's how I got here in Heidelberg, exposed to art history, to humanities on a greater scale, in particular in that particular area. But you may have also seen that we've been working together with people from, with scientists from neurology on a greater level. Biomedical processing is something that I also found interesting there. But without further ado, today I want to talk about what's next up after all this digitization has been taken care of or has been running up steam in the digital humanities. And to get into things, let's get started at the beginning. And that is that we are truly in a time of dramatic change. You can see my slides all right? Okay, perfect. And as Bob Dylan said, the times are changing. And this dramatic change that we're in brings with it entirely new opportunities. And it will eventually have an impact that we cannot even imagine in its scientific, social, industrial, and economic breadth that comes with it. The depth of this permeation into even the smallest details of our lives and our work are compared to the profound implications that this change brings with it, only rudimentarily discussed, I believe. So to say this again, the times are truly changing in a dramatic manner, and they will have, this change will have dramatic impacts on all areas of our lives. And I guess we should devote much more attention to that and much more discussions as we're having today in this meeting on what that actually means. Now, I said that there is great change, but the question is really, what is this dramatic change? Is it really digitization, as politicians and lots of other key figures in our states are actually telling us? I mean, typically it's digitization, right? Which is this magical wand, which is packed out whenever a crisis hits us, like these days. There should be a solution to that. But I'm not so positive that digitization itself is actually this key radical transformation process that we are talking about here. Digitization enables a much greater revolution, but digitization isn't itself this great revolution that I'm talking about. So at the core, digitization is just changing something from analog over to the digital world. And it's true that with the digital, there are many more things possible than were with the analog original, typically. But digitization with that can enable other processes afterwards, but I would argue here that digitization itself isn't, although it has already started quite some transformations, but it isn't the true radical transformative process that we're actually up for, that is still to come. So what is there beyond digitization? What is there beyond just laying out the glass fiber cables that are so prominently discussed in Germany that we're still lacking those? What is beyond all of the digitization process? And I would argue that this is actually what's here stated as AI, intelligent information processing. Now you might think this is just yet another buzzword which has been around for quite some time, but I hope that after this talk, I can convince you that this is more than just switching from one buzzword to another. So let's carefully see what the differences here are. And I would argue at the core of what I'm actually looking for in this next transformative process that will truly change everything that I mentioned beforehand, at the core of that is having machines learn, truly learn, to process information in such a way that they can actually produce new knowledge. Yeah, we're talking not just about changing information from one to another, just transforming it from one into another substrate, but a learning process which is therefore highly adaptive and that can, at the end of the day, take information in whatever form it comes and eventually help us to produce new knowledge. And that's what we, at the end of the day, we're really up for. Now, it's said that data is actually the new oil. And if data is really the new oil, then we should really think about what gives the oil its value. It's not those drilling towers here, although these are very powerful money-making businesses there that give the oil its value. And it's also not, although this is great, the ability of oil to easily store it, to exchange it, and to easily manage it, compared to other media. Because the same is also true for data, right? Digital data is something that you can now, compared to the analog original, easily store, easily exchange via global networks, and easily manage in databases and the like. But I would argue, although this is very much appreciated, and that's what has boosted much of the digitization, in particular in the humanities, but everywhere else in society as well, that this is not what eventually will give the digital, will give the oil beforehand its true value. Not that you could store the oil, that you could exchange it or manage it. At the end of the day, oil always remained this sticky black substance that we had, and that itself did not give oil the value. What gave oil the value? I mean, oil was known about for millennia beforehand. What changed in the last 100 years is all the things that people could do with the oil to lift it beyond being this sticky black substance there. And for that, we needed evidently processing, new ways to process the oil, to transform it into something generally new, which you cannot see that it was eventually made up of oil, all these products you see here at the bottom. And these then are what gives the oil its value. Yeah, these have entirely new properties. And we now need the same analog to that in the digital world as well. Turning the digital data, which is already digitalized analog data or digital born natives, and process that in the same or analog manner as what we've done here with the oil beforehand, into something new that gives the digital data, that conceives new knowledge out of the digital data. And with that, eventually gives us new eyes, a new set of glasses here to the original data, to the original artifacts that were out there. So my point here is, oil has been around long beforehand, and it's not just the way that you can easily exchange or whatever with the oil, but it's the processing. The same goes for the digital data as well. And the key issue with that, and this is really to the core of what I was talking about, is not flour and eggs, as you're seeing here, but what's behind that. The substances that you see here on the slides enable you to do a lot of things with them. And now, being around lunchtime, one thing that you can do with them is create pancakes out of those. Now, the true thing that I want to bring your attention to is that the substances on the left need and require and call for generally different tools than those on the right. A fork and a knife is a great tool for handling a pancake, but it's no good for dealing with the flour and the eggs. And the same goes to whirl on the left side, which ain't gonna help you with the pancakes. So my point is, the digital object is not the analog in a new form. The same as a pancake is not the flour in a new form. We put these substances, these ingredients here together, something entirely new is created, and this entirely new substrate also calls for entirely new methods to handle it. So that means that the digital, contrary to what we've seen so far, enables and at the same time requires entirely new methods to handle it. So let this sink in. And that's where I believe that so far we've been really falling short. We've just transformed something from the analog world into the digital world. But the methods that we use to handle now the digitized data were still reminiscent of the analog world beforehand. Most importantly, it's just been our eyes with which we viewed the now digitalized data and similar other tools that we used to handle the original analog data, we now utilize to handle the digitized data. But with that, I believe that we're not truly sort of leveraging all the potential that has been created by the digitization process. And we really need to make this jump here over from the tools that we had on the left-hand side to entirely new tools that this combination of ingredients, this digitization actually calls for. Now, I believe that the digitization eventually calls for something that Avi Warburg already kind of commanded us to do, and that is turn the digitized data from an arsenal of individual artifacts into a laboratory that allows us to explore them, to open up the content, and eventually transform it into something new. And for that, we need entirely new tools, and they demand essentially computer-supported analysis. I'm saying here computer-supported, and I will touch this in a short while. But new tools for search, for finding similarities in this huge heap of data, especially for establishing relationships. I truly believe that knowledge, which I pointed out beforehand, comes into play when we bring things together which were not on the same page in a book. Then somebody else would have already discovered the knowledge. But it's eventually when you put together artifacts which were highly distributed in different angles of the world, you bring them anew together, establish a relationship. That's when new knowledge is created. And that's where I believe that this intelligent information processing can eventually help us with. Opening up the content and eventually efficient editing tools, content-based analysis. Now, that's what I believe that we eventually need to go for. And I will in the future, will now in the next couple of slides, show a few limitations that I believe that are still there also on the machine learning side in artificial intelligence, and give you a bit of a glimpse at where I believe we could potentially go when it comes down to leveraging these tools, especially in the humanities and other disciplines, other application disciplines. Now, first limitation that I see is the amount of supervision information that we need. What do I mean with that? In this day and age, we're all talking about deep learning. Deep learning typically means that we are looking at a deep neural network. Deep neural network for me here is just this black box which you're seeing in the middle. A black box receives input, which in art history, for instance, would be visual data, images, videos, and the like. And eventually it should spit out either an annotation of these images, some nouns, verbs, what's going on in there, whatever that is. So image in, and something should come out. Supervised learning means that deep learning has grown up over the last decade and become strong by having now millions, hundreds of millions, even or even more, images that it has been trained on. And at the same time, annotations for what it's supposed to see in this digital data. So somebody gives you the input and it gives you what the output should be. And then the neural network is squeezed in like in a vice so that it cannot escape. You give it the input, you give it the answers, like a little child, and show it and let it look out of the window and say like car, 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 airplane, airplane, airplane. And eventually there's no other way than to come up with the right answers that you want. What's the problem with that? The problem is that data, especially visual data, is really cheap. Yeah, it's exponentially exploding, the amount of visual data that is there available. But labeling is costly and will always be costly, even with Amazon Mechanical Turk and similar tools, and especially when expert knowledge is required in disciplines where you need experts to actually give the right answers. And that means that the visual data we can have in numbers that we cannot handle, but the annotations will always be scarce and will be a limitations there. So can we conceive of an approach that can learn what's there in an image, or that can learn about our world without being required all the answers during training? So essentially, I'm envisioning an approach where our brain is kind of on a couch, just watching what's out there and trying to understand the structure of our world by merely watching without being told each and every bit out there. much like little children going out, exploring the world, and by that starting to make sense of the world and try to understand it without being told each and every bit about the world. Now, let's look at one example that we've been exploring together with a Assyriologist here in Heidelberg, Stefan Maut's group, who got a Liveness Prize pretty early on and produced or assembled a lot of data there. And that got us thinking how we can follow up this self-supervised strategy in the process of cuneiform transliteration. So as you know, there's a lot of tablets out there. There's unfortunately nobody speaking this language anymore. And the question was back in the day, how to actually translate what's on these tablets. And the first process in this translation process is actually process of transliteration, telling where the signs are and what sign you actually see on this tablet. And then you can kickstart the entire transliteration process from there. And we developed a system for that, which now also got published in +1. And the code is available on our website. There's even a demo there if you want to play with that. We can take tablets, clay tablets here, as from Neo-Assyrian period. We've mostly explored it on, but other periods as well, where we can take that as an input. And then we develop this cuneiform sign detector, and eventually spits out bounding boxes, tells you where a sign is and what sign is there on the tablet. Now, where does this self-supervision come in? Point is that it's really tricky to mark all of these bounding boxes and then tell for each bounding box what's there. But what is available are images of clay tablets, for sure. I mean, that's what Assyriologists do, right? They dig them out and then they take a picture of that. And we here are fine with just 2D imagery, no 3D images, although it's actually a 3D writing that you see in front of yourself. But we just here develop an approach which can handle everything with 2D because that's more frequently available, and then utilize a bunch of transliterations. The transliterations don't tell you where something is on the tablet. It just gives you the codified version. And then we have this problem of telling, like, on the tablet, here's the tablet image, where's which sign, which is something that we need to, in an intelligent manner, have the algorithm figure out, like how to map transliterations on these clay tablets, and by this process understand what is meaning what on this clay tablet. Eventually understand the writing that's there by solving this correspondence problem. Now, without going here into details, it's an iterative process where the algorithm itself comes up with a few proposals. Evidently, there's a lot of holes there. It cannot explain the tablet, especially when it's starting. Just a few indications like where could be what. And then based on that, it can make suggestions about what's in the neighborhood of the individual signs. And then by that, start to understand entire lines, as you can see here at the bottom, and understand the entire clay tablet. So here's the interface that we built for this learning algorithm in action. So you can see you can detect signs, localize them. You see their transliterations there. You can toggle the confidence threshold, as a lot of this clay tablet is damaged. You can say, like, I want only the signs that the detector is entirely certain in, or I want other signs to be detected as well. And then you can correct sign annotations there, have the algorithm eventually ramp up its performance based on the feedback that you've provided it. And with that, start more and more to dig deeper into a bunch of clay tablets. So essentially, the ensemble of all of these tablets helps you to figure out what's on the individual clay tablet. Now, things are evidently not limited to just these ancient writings, but and that's where we started off, in particular with visual retrieval. So you're having a large corpus of images, for instance, here from the humanities, but whatever else that might be. And the typical problem that you have is you want to search objects in this database. So you may want to mark here this horse or two horses and reason about their spatial relationship, and then ask, like, where in such a corpus do I find similar objects with a particular spatial relationship, if you care about that. So that's something that you see here. That web system is also going to come up on our website again. We're just clearing that and debugging a few things in the web system again. And here you can see it already in action. So you can define a query with this system, like tell what you're looking for, visually marking such a bounding box, and then give it a name if you care, to save it later on and search through your database, all just based on the visual data that you've marked here. Show the results. So here you see a bunch of results there. And then you can zoom into the individual retrievals that you have. And you can later on also, this is going to show, here's a light table, and we'll have another presentation on that. And then you can refine the search by means of user feedback, say like, hey, I was more interested in something along these lines and less so much about something in another direction. With that, refine your search and have the system then continue learning what you're actually interested in. Now, I already showed this light table here that we were considering. And that gives you an easy access to a huge volume of data where you can zoom in, reason about the relationships between these individual images, and most importantly, also try to structure them by your own. So let's just wait for that demo. So you can see like an entire corpus being displayed. You can zoom into that, and you can define certain groups of images which you believe have certain relationships or which you're interested in. You can add others to this particular part, and eventually have a kind of deformable light table that we are, other than that, all seen here in one or another aspect. But here you can semantically sort of change the display on this light table. Now, with that, I would like to switch gears to another problem that I outlined beforehand, beyond the supervision. That's the interpretability of approaches in the digital humanities. Now, what do I mean with that? Most of the processing, intelligent data processing that we see takes images, for instance, or other media, and processes that by reducing the data and eventually coming up with an abstraction. Now, what do we do all of that for? I mean, we are not doing intelligent information processing, machine learning, deep learning, and so on, to just take an image and have a bunch of numbers come out. And we're doing all of that so that at the end of the day, this representation that comes out of this intelligent abstraction process that is running here allows us to more efficiently search, categorize data, do a network analysis, and whatever else that is, so that based on this search and categorization and so on, experts can eventually understand the original artifacts that were here, describe them, analyze them, and the like. So that's the usual pipeline that we see whenever machine learning approaches are applied to data for intelligent data analytics. What's the problem with that? Well, the problem is that this part here, the key part of all the data analysis that reduces the megapixel images, for instance, abstracts them, comes up with an abstract representation, that's throwing away a lot of information. We don't necessarily know what information is thrown out. At the end of the day, the deep neural network or whatever algorithm we are here using is acting as a black box. Data goes in, something else comes out, but we have, especially when the models get complicated like they do in deep learning, really a hard time understanding how this abstraction process is going about and which is thrown away. Now, this is tricky if at the end of the day, you're the scholar which is making your decisions based on these categorizations here, and these categorizations are ultimately built on this abstraction. Because depending on what information gets thrown away, your effective analysis here at the end of the day is also going to change. So the question is, can we make the intelligent processing that we're having here interpretable by the human user? Can we have it explain itself to the human expert so that the expert can understand what information gets thrown away, excuse me, and how to potentially even change that if they care about. So that this is not a black box anymore, which you have to trust in the process of discovering knowledge at the end of the day. Now, this becomes particularly tricky when you're looking at images here, because I said, like, much of knowledge comes about when we're establishing relationships between images. And relationships, in particular similarity between images, is multivariate in nature. What do you mean with that? We can talk about the similarity and dissimilarity between images in multiple different manners. The human figure can be similar or dissimilar in terms of the viewpoint that we're looking at, in terms of the body posture, in terms of color, texture, and even iconological properties, like young and old, rich and poor, which you're seeing here. When we're just saying, give me something that is similar, what similarity do I then mean? And what similarity should the machine learning algorithm should actually have learned? Now, what I'm going to show you now are processes that help us to disentangle these different modalities of similarity here, so that the machine learning algorithm can then concentrate on several individual aspects individually, learn to contextualize them, and learn to essentially explain to a human user these images are similar because of the greenish relationship here or this bluish purplish relationship, but not just say like they are similar. So in essence, we want to understand eventually images with images, meaning that we still have this data reduction here, which output is then used for whatever follow-up processing you might conceive. But we will then design a second neural network, which allows us to reconstruct whatever we had here and synthetically generate as images so that we can look inside this first network, which helped us with the analysis. So let me state this again. We have here our intelligent information processing, our machine learning algorithm, which abstracts the information, but we design a second algorithm which helps us to look inside the first network, in particular by generating images which tell us which information got lost, which information the algorithm has focused on when it tells you two things are similar, so that at the end of the day, you as a scholar, when you're utilizing this first algorithm here, can look inside the black box and understand how the decisions came into play. A little bit more concrete. Well, consider an algorithm which, now images are easiest thing to demonstrate, but this holds true for all data processing. Let's take an image and run it through a neural network. Neural network typically are a bunch of these processing units which create intermediate representations. We also call them layers. So image goes in, and here is just a bunch of numbers. They don't mean much to you, and neither do they for me. This is just a lengthy vector of numbers. And the problem is that at the end of the day, here comes a decision which you really care about, but you don't know what these intermediate representations mean, what these intermediate abstractions mean. And to solve this problem, we designed this interpreting neural network, which I showed you beforehand, which takes this bunch of numbers that nobody has an idea what they mean, and invertibly maps them over into numbers which have a meaning to you, semantic concepts that have a meaning to you. Like in this case here, does this person wear glasses? What's the age of this person? What's the gender of this person? And so on. I guess we all agree that these numbers up here, we have absolutely no clue what they mean. These numbers down here, or these concepts down here, they make sense to us. And the point that I stressed beforehand, that this thing here is bijective, that this is invertible, means that I can go from top to bottom and from bottom to top. I can go in either direction, which also means I can manipulate one of the concepts here at the bottom, for instance, change the age, and then see how it affects the representation that I had up here. And see if now the gender, for instance, changes, in which case things were absolutely wrong. This representation would be bogus here, or if it's correct and you see here a gender change, for instance, in place. And secondly, it allows you to then deal with neural networks, which are black boxes to you, in a semantically meaningful manner, meaning not looking at these values up here anymore, but really at semantic concepts here at the bottom. A concrete example, it could, for instance, mean that you take an image and you typically have a person detector or even a person instance detector, which then tells you which person you're looking at, or if you're looking at a person at all, or which person it is. And then imagine you're having your person's instance detector, and you want to understand what Van Gogh would have looked through the eyes of Van Gogh, what Van Gogh would have looked through the eyes of Paul Gauguin or another artist. So in essence, you want to understand if this algorithm up here has understood the concept of what makes Van Gogh Van Gogh, to detect a particular person based on actually what the person is, or maybe based on the style of this photography here, of the day and age that the photography was taken in. So in essence, can we disentangle the concept of a person or a male person as opposed to a female person or whatever else that is, object detection, object categorization, the sujet of a scene in more general understanding. I'm going to show you some examples which are beyond persons, but just scene recognition. So the sujet that you're looking at, can we separate that from, for instance, stylistic aspects of this particular scene, which you see here at the bottom amplified? Can we then tell if this network has really understood the person for the person's sake, or the sujet for the sujet's sake, or was it other aspects that actually mattered? Maybe there's something written here at the bottom of this image that gives away what it is. Maybe it's the stylistic attributes and so on. So in essence here, can we now disentangle the sujet from style, for instance? Here you see an example. In computer vision, it's typically called artistic style transfer. I know that style and art history has a really difficult sort of standing these days, so take this with a grain of salt just because it's called that way in computer science. But for me, it's here more like this aspect of disentangling the different properties which might lead or which lead to similarity of images or not. And here you see how you can alter the style, although, or in a way that the contents of the scene still remain mostly in place here. So telling you that the network that we had beforehand has typically understood the sujet and not so much like entangled both of them with another. So if you have this approach in action, you can also utilize it to create funny videos from that. So here you see YouTube videos downloaded, and then in the individual images here at the bottom, artistic images, and the stylization process, as it's called, in place. And you see that the content isn't changed in this process, which here is the thing that we wanted to analyze. So let me fast forward and tell you that we had talked about this disentangling. I started off considering here the sujet and the style. This obviously is a very general concept. Let's say you're interested in the shape and the appearance, which is like color, texture, and the like of an image. Let's say I have a single person down here, and you care about the appearance, the identity of this person, everything that makes this person here the person in this particular image, and you care about the shape, the body posture of this person up here. So can I render this person down here with the body posture of this person up here? Resynthesize this. And that's what you see here. Now, attached to that, this image is entirely hallucinated. I've never seen this person here from the front. So what you see is the understanding of this algorithm about regularities in visual images. Having seen a lot of persons, it can start to hallucinate, well, it looks like that from the back, what this person might typically look from the front. Not only that, I can, with this still only this single image down here and other shaped targets like these here, hallucinate what this person might look like if they walked, or if you look at them from different viewpoints, and hallucinate all of that in place. So in essence, you take a single image, you alter the body posture, and here you see then renderings of what this person might actually look like from these different viewpoints or with these different postures just from a single image started, to essentially see if body posture and appearance have been disentangled, You can take this in action. Here you see a YouTube video, 3 grad students from my group, and then they were just in a, we just took pictures of them in an office environment, so they never played tennis or something like that. And still you can render them doing all of these sports, showing that the algorithm has understand something about the concept of the person. So you see the person is not changing as I'm doing that, although, and we've only changed the body posture. Now, it's not created for, I don't know, impressing your Instagram friends or something like that by doing 1,000 chin-ups. But what we were targeting is actually a more controllable visual synthesis to show that, or to understand what the algorithm has already understood about scenes and what not. To see the limitations of an artificial intelligence that tries to make sense of images. And for that, we've taken this actually at a greater scale beyond individual persons, like I've shown you beforehand, and try to go into controllable visual synthesis here for arbitrary scenes. You see 2 examples, and these here are generated. So even after the pandemic, you will not be able to travel to these places because they don't exist, all fabricated by the computer, much like all the images that you see in this video. You see the sequential generation process of our algorithm and how it then starts to hallucinate scenes. Again, like with the underlying scientific enterprise here being, what can we understand about the relationships in individual scenes to make, to eventually conceive of the entire scene? What do we know about the relationships in images, and how can we utilize that to then render novel scenes which you're seeing? So this level of scene understanding, which is now exemplified by the synthesis process, giving you a handle of what's going on inside the black box. This allows you then to handle a lot of individual problems. Let's say, for instance, you're having a layout of the scene. You want here a tree, and this here should be green grass and sky and so on. Then there's evidently not a single solution to this problem. And this algorithm, being probabilistic in nature, can then sample a lot of different solutions to this particular problem. Or you take a depth image, so the distance to individual points in the scene, and then synthesize a lot of answers to that. Image completion, let's say you only have the upper part of an image. Can you hallucinate what the bottom part of this image looks like? So that's what you see here in place. Or super resolution. This image here should be lower resolution. I know how this comes out in Zoom. And here's then high resolution examples, a synthesis of the image. Or depth layout, here you see depth to image. So you start off only with a depth in the image provided, and then the algorithm is supposed to synthesize the entire images, which you see here in place. So all of that telling you what the algorithm has understood about relationships in the image and what it is still lacking, and also helping you to understand the ambiguities of images or of this information that we provided the algorithm with, and what the algorithm can do with these ambiguities. So let me conclude here, as I believe my time is pretty much up for this presentation and want to start with you into the discussion. Let me conclude. I believe that digital data enables entirely new ways of access, and it also demands these entirely new ways of access. We need to go beyond the digitization and enable to eventually work computationally with the digital. And with that, I mean that we shouldn't tackle the digital in the same way that we tackle the analog, just by means of our eyes, for instance. We need new ways to actually deal with that. With that, we can then eventually sort of enlive the transformative nature of the computational analytics that are underlying, and establish new relationships and cross-linking of information, which eventually will help to create new knowledge from the digital data. I believe that we need an interpretable model for deeper insights into the analysis. I find it somewhat tricky that digital humanities in particular have just been utilizing every tool that's been around, and I guess we should demand more from computer scientists from research in that particular direction to not just come up with tools and models that eventually give us a direct solution, but also give us a solution which is interpretable, understandable to the human user, which tells how the decision came into place. And I truly believe in a computer-supported analysis, not a fully automatic one. I doubt that the computer will eventually sort of replace, and it should not replace, other fields of expertise, but complement them and support the decision-making that's going on there. So let me stress that again. I doubt that the computer should ever make the decision. It should support the decision-making process in other fields of expertise. So in short, I think that there's much beyond digitization to take place, especially when it comes down to opening up the content and creating knowledge, transferring, establishing relationships between the data, and then the final analysis. And with that, I want to thank you, and I want to thank you, the great team that I'm proud of that did all of this work, and I'm happy to answer any questions if you have.
Thank you very much. This was a cavalcade through papers, which in the humanities would have taken a lifetime, but most of the publications everybody has seen were between 2018 and 2020. That's computer science.
As rapid developments taking place.
Exactly. Thank you very much. This was great. Yes, I see there is one comment in the chat, which is my speakers, or is it the mic? Is occasionally? Yes. So there was a disturbance in your voice from time to time, but I think I don't know. I understood everything, so I didn't say anything because I thought I make it worse if I sort of like get into the feedback loop. Okay. So the standard procedure is obviously that people need some time to marinate and then ask questions. So please put your questions in the chat, and then I sort of like will take them one after the other. And so if nobody starts, if somebody lifts their hand, lift your hand. Otherwise, I ask a question. So there is a really interesting thing regarding the way you presented what you presented. It was very, very impressive. But indeed, this thing that this is just the last 2-3 years, right? And so will we ever see something like a definitive sort of stabilizing textbook version of what we need to know in pattern recognition, right? Like we still talk about, like when you say multivariate nature of similarity. I mean, this is literally Wittgenstein. I mean, he already said that, and we're still talking about it as if it was this kind of uncanny thing, while at the same time humans operate with it every day. And there probably are some concepts that are not only rapid development, but there are sort of these kind of constants where I say, okay, there's some things we now can operationalize, but we sort of get an idea that they were the same thing the last 50 years, they will probably the same thing the next 50 years. Do you see this field stabilizing, or do you think this particular area of research will again look absolutely completely different in 5 years, for example?
Interesting question. My group has been doing machine learning for quite a while and computer vision for quite a while, and both fields are heavily interlinked with another. But at the same time, it's still two different fields which have a lot of contact with another. And that gives me a bit of perspective on either side there. And the perspective is as follows. For years, when I've been teaching the lecture, I felt it easy to give students literature advice for machine learning, because there are established books which have been out for decades. There are new versions of those coming out, and yes, there are new books and they're great. But all the basic concepts in machine learning, the ones that work, have been out for a long time. In contrast to that, computer vision literature was really tricky. I was mostly pointing at either older books, or mostly pointing at papers, because there's a lot of new development. There's been no definite answers as you were asking for. And then came the deep learning revolution. Neural networks, as we all know, have been around for decades, but they were always like coming and going, coming and going. There's been these AI winters, and with that, they disappeared. And until almost 10 years ago, until 2012, and it took a while till it was like permeating through machine learning, neural networks were again like in this niche discipline. And machine learning research, I would have said, had mostly stabilized in the sense that the things that you, as people that apply it at the end of the day, would care about were things which were mostly in textbooks. And then with deep learning kicking in, there was a lot of research, and as you were showing or like highlighting with my talk, most of the development is now, because we're in exponential growing phase, always like the last 2 years or something like that, because like every year there's new things coming around and you feel things are almost outdated. And I would say that we are still in this phase that there's lots of new things coming out. I mean, over deep learning, there's also textbooks existing, but I feel like most of that is already outdated again, because it's not like the 60s had all the answers to it, but it's like new and really great tools coming about. Now, one more thing, I already gave you this grain of salt there that people always said like, yeah, AI, that's like the brain or whatever else. And then a few years later, they figured out, hey, it's only a linear classifier or the like. Yeah, and we have the next AI winter. Is that the same thing? I would say with this time deep learning being around, we see a different quality than what we used to have beforehand. And that goes in two directions. Like with the perceptron, which is like the most humble form of an artificial neural network, people called it being the brain or almost the brain. And then they realized it's only a linear classifier. This is essentially a realization of a line or a hyperplane through space. And that's not the brain by no means. And this overstatement then led to a hype beforehand and afterwards to as much of an AI winter afterwards. Now, with this time around, there's been also quite a bit of promises. But for one, we see a lot of applications where you might not believe in deep learning or whatever else, but it's working, right? I mean, you might not believe in lift or whatever other, or gravitation, right? But you open your window and you fall down and you don't need to believe in it. It somehow works. And from application point of view, I would say that deep learning is much closer to that now than it used to be ever beforehand. So it's not just like overstated promises, but yes, they are there. Yeah, so we still should be careful. And that's why in particular, I was also pointing at explainability, because it probably doesn't help you, at least in a lot of domains, especially when you're talking medical or whatever else that is, about critical decisions, and you have no clue how the neural network came up with the answers that it provided you. That's, for instance, one of the things where I believe that things might eventually be critical. Now, the other difference to beforehand is that I see less people these days, especially less key figures that were involved in this time in deep learning coming around, still claiming that this is like the brain or whatever else. And you can see it at the core of the denomination there. Core to deep learning have been the convolutional neural networks. And most people even just call them convolutional networks. There is little of the brain or of neural in there, or at least much less in there than used to be there beforehand. It's essentially a convolutional filter base. Yeah, and nobody really thinking anymore that this is the brain or something like that. It might be here or there inspired by that, but we're far away from that. And I guess that helps to relieve part of the hype.
Nice. So to specify, before we take other questions, like what you just said with the brain equivalence, I think it's quite interesting, because brain science, neuroscience, is sort of limited in a sense because it focuses on neural science. Like artificial neural networks necessitate artificial neural science, but brain science sort of focuses on neuroscience. But the brain is much more than just neurons, right? Isn't it? So is there, do you see that there's at the same time a resemblance going on where your work could learn from neuroscience, while at the same time more humbleness is necessary when looking at the real thing, or is that, would you underscore that or subscribe?
And that's interesting that you mentioned this. Yes, the brain might be more than just neurons, and there's a lot of discussion in neuroscience these days. What else is out there which we haven't discovered as of yet, and what the importance of that is. But at the same time, I guess many people in my field would be happy if they had only sort of gotten to the level of the neurons in the first place, right? And even that we haven't fully lived up with. Can we still learn? Yes, for sure we can. See, with learning, the tricky thing is like, if you just take visual understanding, the information is evidently coming from the eyes, from your retina, right? And the information processing starts at the back of your head in the visual cortex. On the way from the eyes to the visual cortex, and then from that, it's going to project it back forward in the limbic system, other areas, and so on, where you start associating things to something and say like, oh, that looks like a dog, and I like dogs, and so on, or I don't like, and then you run away, whatever else that is, right? And triggers the processing. But only the first part, from the eye to the visual cortex. The information runs through LGN, lateral geniculate nucleus. And information there at the core of your brain gets linked, not just information from the eye, gets linked with information from everywhere else in your cortex. As a matter of fact, 90% of the information which get into this particular part of your cortex, of your brain, is coming from everywhere else, but not the eyes. State that again, like only 10% of the information come from the eye, 90% come from everywhere else. And that led people to think that visual understanding is AI hard, meaning you need to understand the entire brain before you can eventually understand how visual processing is going about. And that is where I believe that the inspiration and so on is great that it's there, but at the same time we see parts of the shortcomings. It would mean that we would probably only understand this thing if we've understood this entire thing totally. At the same time, maybe the analogy with flight helps, right? I mean, people watch birds and so on, but if you look at the jumbo jet, there's little resemblance of a bird there anymore, right? I mean, all this nicety of very light and not noisy flight of birds, and then you see this massive jumbo jet with its engines and the fuel that's consumed and so on, and still the same physical process at the end of the day holds both in the air. And maybe that's for now the motivation that we can take at the most core part there, but I hope that in the future we will also take more of an inspiration than just a physical principle from it.
Mm-hmm. Thank you very much. So we got a number of questions in line. A simple one is here from Antonina, who's a PhD student in our group. Is it, maybe I just read it. Antonina, you wanna ask yourself? Ask yourself.
Hi, can you see me? Can you hear me?
Yes.
Can.
Thank you very much for the talk. To be honest, as an art teacher, I am very interested in this search engine that you showed that could find the different parts of the images. Can you tell if this project is open and I can go somewhere, take a secret link, or not a secret link to use it?
This project is open. There should be should have been a link also on the slide. We are presently putting together another publication. And with that, we were sort of redesigning parts of the system again. And that's why it was briefly offline. I believe like right now it's offline, but it should shortly get online again with the new features being in. So yes, you should be able to utilize that.
Thank you very much. Mila Oiva, who's a senior fellow in our group.
Hi, yeah, thank you. So fascinating to see all the kind of like research that you're doing. My background is in cultural history, and I do research both in kind of like this fake history realm, and also I'm starting a project on Soviet audiovisual culture. So my angle is of course of cultural historians here. And I think that particularly these image generation algorithms and tools that you showed at the end of your talk are really interesting. And for instance, as a historian, I could see many applications that, for instance, kind of like if we have missing historical data, maybe we could generate some kind of like probable contents that are missing and so on. But I could also think about some kind of less ethical ways of using your tools. Namely, of course, we are all aware of like images appearing in the internet showing that somebody is doing something that he or she hasn't been doing, and these kind of like reputational harm and these kinds of things. So all this just led me to think like, and I would like to ask you, what are your thoughts on kind of like the ethics of the tools that we create, and kind of like how much do we need to think about the possible different kinds of uses of the tools that we create, or and how much do you think that that would limit or that limits what we can actually explore, and how much should we actually kind of like think about the ethics of AI in general, and what are we doing overall? But thanks, really interesting examples.
Questions that you brought up are questions that have been puzzling me for quite some time. And I guess that's questions that we should not avoid, questions that we should actually actively seek to discuss, not just as scientists, but as a society as a whole, and which demand to be, especially in democratic societies, to be discussed as a society as a whole. Before this pandemic kicked in, I had a bunch of speaking engagement with governmental agencies which were actually concerned about the risk that deep fakes and similar algorithms, deep fakes, as you know, were just limited to faces. What we developed works with entire bodies. That something like that has on societies. And the discussion is evidently like how to handle that. Now, for one, I believe that scientific progress in that particular direction will take place. It's nothing that we can these days shut off. I mean, it's not that we can bring an end to deep learning and there will be no tools which will eventually generate images anymore. And for that reason, we eventually, so that solution won't work. Yeah, like pushing our heads into the ground and hoping that this is not coming place. We all know about actors out there, other countries will eventually put this into action, and we need to find a way to handle that. So that's for one. For second, and that's another observation which I found interesting, is that so-called shallow fakes, things for which you don't need any artificial intelligence, computer science degree, or whatever else, are pretty luring at the same time still. So you remember this Nancy Pelosi video, which was just a slowed down version of the original. You need zero artificial intelligence for that. And still a lot of people just believed in that. And that tells me that a lot of lies, visual lies, are believed if they just fit the story. And if these are so attractive, I guess that deep learning, or the fakes that come out of deep learning, are, I should not say like one of our least concerns. They're surely one of our, should be on the list of our top concerns there, but we need to attack the problem on a different level and not just look at the most high profile scientific problems that are created there, or tools that one can utilize to create more or less uncanny deep fakes, and how we can actually handle those. But the solution always needs to be a solution where we can tackle the reasons that people actually believe in something which is so obviously wrong, right? And that is not a technical solution. That's a solution which needs to start at the very bottom of our educational system, Why do people want to believe lies that are out there where everybody can see that there's probably other reasons to that? Things that we see in this pandemic again, like societies just destabilizing and simple lies just winning the day. And it's not the clever engineered solutions that eventually do that. I agree that the clever engineered solution will make it even harder to battle these things, but I guess our problems are on a much more basic level, and we still haven't found a solution to that. If you want, we can discuss this later. Yeah.
So I would, I don't know. Let me do a little bit devil's advocate here, right? So you say we should actively discuss this not only as scientists but as a society, and then you say, you know, there's shallow fakes like Nancy Pelosi's video being slowed down. So let's like that argument, I think we can just dismiss by saying, okay, that's whataboutism. Just because you know, Trump is bad, that's not an excuse for Matt Gaetz to behave badly. And just because I don't know, Helmut Kohl took money doesn't make it better when somebody else from some other party took money. And so so we're left with this thing. We should discuss this as scientists or as a society.
No, wait. My point was not like before, because people do shallow fakes, the deep fakes are right. That was not my point. The point of discussion here was because people can be tricked by shallow fakes, and not only by super crafty deep fakes. I guess the way that we should tackle it should be a way that is not just dedicated at super crafty deep fakes, but we should understand. That was my point. Why do people believe even in this most stupid shallow fakes? And if we cannot find a profound answer to that, coming up with something which only answers why people believe in a Hollywood-produced deep fake, which nobody can tell the difference between from reality, that isn't, I guess, not the true question that we should actually ask. But why do people want to believe in lies? Yes. Why are people attracted by even the most stupid lies that are out there? And if we cannot even answer that, then I guess these other things are even more advanced.
So let me pick an example from my own work, because then it doesn't make the impression we're sort of like unfairly criticizing it too crazily. So if I have 200 million subway records from a city, and I'm able to predict crowding at a subway station 3 hours before it happens, based on just counting from how many train stations people come when they check out with their ticket at the train station. And that is used in the transport authority of that particular large Chinese city. You can obviously also not only prevent crowding that is sort of harmful because too many people want to have a Halloween party, but you can also prevent, for example, a demonstration like in Hong Kong on the other side of the subway, passing the sea. So obviously there you have a question where you say, okay, what is actually my kind of responsibility in this, right? And can you still hear me?
Yeah.
Okay.
All right.
So what is my responsibility in this? And so the responsibility can obviously not be waiting for the society to discuss it. The responsibility as a scientist is to build in fuses or give people the information to act on it. For example, to publish what the potential is. Like, for example, what we hear with the Neuralink thing, you know, you cannot just say, oh, we're going to heal Parkinson. No, you need to actually point out that this is methodology and technology that is developed in order to fulfill the dream that is written up by the Rand Corporation of what can be done in terms of like influencing soldiers, which is totally unethical if you look at the face of it. And we have to decide as a society to say no, but we can only say no as a society if we have sort of informed basis in essence. And right now, I don't see this in this way. Like, for example, we do applications that we do in art history, right? Like this search engine where you can actually look for certain things. You search for windmill. You can, of course, in the same way find nuclear submarines. You can in the same way find, I don't know, people who grow pot in the garden. And so the key thing is this can be used for all sorts of things. And as such, the question is, how do we actually deal with this? Is this not our job to actually at the same time utter this and saying, okay, this application does the following things, which has the following spectrum of use. So obviously, you cannot be responsible for everything you do, but it needs to be one needs to have this in the loop, I think. And so I think there's a question not to you, but to all of us, is how do we actually deal with this with cultural analysis? What is the dual use of cultural analysis?
Correct, but the question is really like what all of us eventually means. I believe that some of the things that you said, I would have said were probably true 5 or 10 years ago, but I would these days say that we've been talking about image synthesis here, and my answer to that was already about deepfakes. Deepfakes is a term which was coined evidently in the greater society and not just in a scientific conference or something like that. Meaning, like, I truly believe that the implications that visual synthesis has for society are these days, like over the last 3-4 years or whatever else, have been understood by most people already. Other than that, the term deepfake is negatively coined, right? I mean, it's clear that there's negative implications. It's not like the example with Neuralink that you mentioned, that people don't see where this can potentially go. I would argue that everybody who had heard about the term deepfake, and apart from those who just use it as a tool for their mobile phone and fancy up a photography or something like that, they know that there is at least some negative implications to that. That doesn't mean that they know like that this can destabilize our societies and all of these things, that they can think like where this could potentially lead, and what this means with things like voting business and so on. I guess everybody has also understood this since at least the last American and before the last American presidential elections. Now, visual search, I also believe that these days people have an idea where this can go. In the state of California had banned, and other states as well, facial recognition software, meaning like the society had already a discussion about the pros, banning violence there and so on, or stopping crime, and the cons, the supervision of an entire society, had this already in the Western world. So I would believe like over the last 5 years, we already made the step over that. And it's not that modern deep learning, artificial intelligence, and so on, our society as a whole would still be overly positivistic about that and think like, yeah, the technology is just out for good. This is something that I assumed in what I just said, and that's why I did not start off like, hey, wait, I mean, it can also be used for negative sort of purposes, because I believe this is already out there. If not, that's what I want to say. There are profound negative implications. It's not like the physicists, like, which only discovered afterwards, after World War II, oh, shoot, I mean, that's what you can do with that, right? I guess these days it should be clear to everybody who has a little bit of education where this can potentially go, probably not in the full effect. But what I meant with that is, it's not us as scientists, especially not us as computer scientists, and in particular, not the computer scientists, not me, employed by some big companies, big tech, who are the ones who should tell where the limitations are, what we should do as a society with that, and how we should handle it, what we should ban and what we shouldn't ban. That, I believe, is something that belongs in a democratic society into the hands of the entire population, which should be a democratic process. Should we ban facial recognition or not? We should lay out as scientists the pros and cons, but it's our elected governments or the people in general which eventually have to make a call on that. Yeah, what should we do with visual synthesis and so on? I believe that certain things are tricky to stop. And now comes the second thing. I said these things particularly from the angle because I always hear this question for, isn't there a technical solution to that? And I was with that much more pessimistic than you might have assumed. I started off saying like, hey, there are shallow fakes out there for one reason, not saying like, hey, don't care about deep fakes. No, for the very reason that I say like, I doubt that technical solutions will get us out of that. We need to start in our own brains. And if people want to believe lies, then a technical solution also won't do that thing. Yeah, sure, Facebook and the like can come up with filters which make sure that you're getting a less biased view on the world. But if people just want to believe certain lies, you've seen network analysis on that. I, in these governmental conferences, seen some network analysis, which I were probably not public before. And I've seen these tied up clusters. And they're out in the Western world, right? They just need to step out of their homes and they would see that world is not flat. There's more out there, right? But if you lock yourself up and that's all the friends that you have and you don't want to see anything else, you can shuffle them in what you believe to be truth, like a less biased view of the world. And I doubt that you will still change their mind anymore. And that's why I said we need another approach than just a technical approach to change minds if people actually want to believe lies. And still, and that's the other thing that I back then did not say, I believe that the only way to actually tackle on a technical level, fake image synthesis and the like, is actually the discriminator that comes with when you're actually developing new ways to actually doing synthesis. So in short, these approaches are developed in adversarial fashion, right? So you have two networks battling against another. One is creating images and the other one is actually detecting if they're fake or not. So the best way as of now to detect fakes is actually the work that is dedicated to working on this visual synthesis, because with that we're having the best detectors in our hand. And now a positive note on which I want to end. So far, the detector always wins. That means detecting fakes is still easier than just generating them. So we're not in a lost world as of now. If that would eventually be true, then we would be in a different realm.
Interesting, interesting. So we got two questions coming up. A yes/no question in between. So would you agree that in addition to dual use, there's also dual interest? Like if 90% of all geologists work in the fracking industry in Texas, which is actually true, you have a hard time talking to geologists about the ethical problems of, basically pumping dirty water into the soil because they have a dual interest. They earn money with it. And to be a very similar thing, there is very little money to be earned to be an ethical machine learning philosopher or a digital humanist or cultural historian. There's plenty of money to be made in actually treating it like oil and not caring about society. So that is something which I think probably we have to leave open. We cannot fix this, just like we cannot fix the Palestinian conflict in a conversation between an Israeli and a German postdoc over a lunch discussion. But I think this is a major problem, and it would be great to if you could think in that direction, because we're sort of like the people who are teaching stuff like that, like in your case, computer vision or this kind of multidisciplinary aggregation of cultural analysis. We're sort of the last stop before the dual interest kicks in, right? So when you enter your career, you're fully in this thing in essence, and so there's nobody there's no, you're decoupled from the responsibility if you go down the one path that is not the ethical nicely one. So let me rotate this out. I don't know if Mar or Mark lifted their hand first. Who wants to go first?
Mar, you were first.
Okay, Mar.
Hi, very nice presentation. Actually, I was surprised that you went to this direction, because like at the beginning, I was thinking you will talk about more in other way, but yeah, I'm doing my PhD on latent space navigation, and I have a lot of interest on latent space navigation methods. But I actually doing my PhD in the Baltic Media Film and Art School. I'm a practicing artist, but I have a dual. I mean, I am a computer science too. I graduated in computer science. Means I do art practice, but I program and I do software and so on. And I'm doing generative stuff. Means and I'm in the CUDAN where we do data culture analytics, and just do like you are saying, like you generate and then like this you see how the black box works. I was like really fascinated that you kind of took this approach, because that's actually somehow how I want to do and I'm doing. And yeah, Yeah, just like maybe it was not a question, it was like more like a reflection. And talking about this, the ethics, I think we should put the point more in the suggestion algorithms. If you like, because synthetic, I'm in the synthetic part also, doing synthetic, and I think that once you have to train everyone that anything that you see in images cannot be might be not real. That is like something that we need to kind of like put in the society, that like image is not anymore like a grand true. I mean, like it might be fake. I always try to explain people when I talk about this topic that I think for me the more threatening is actually the text, because like there is a lot of interfaces where we interfere with people like every day with email and every day with other interfaces where you actually they might trick you much easier than images. Like images is still like well, one is the grain of perfection that they have. There's still like some things that you might notice something, but the next is like I'm saying, like we already know that in CG, in 3D, it's like possible to do everything. We saw Toy Story many years ago already, but in this kind of text is different. But I think the kind of, if we need to look the ethics, I think we should like move to the target point where it's actually more important. That is a suggestion algorithm, which actually they give garbage to people, and they actually know who to target, when to target, and repeatedly targeting some vulnerable people, and in the vulnerable times means that and there is no discussion about this. Like mainly to play, mainly is, for example, timeline of Facebook, timeline of all this kind of they are not linear. Like people don't understand that they just work in dopamine shots, and they're designed to kind of like take your attention because that's attention economy, and they are designed for actually pushing whatever is actually going to have you more attention. And if they see that you are kind of going in the wrong direction on news, they don't fucking care. They just like give you this kind of like conspiracy theory news all over and over, that because you get excited, you get dopamine, bim, bim, you get more and more and more and more. And I think people should be actually be touched more. And I think this is like another topic that you mentioned about the schooling some moment, really brief now, when you were answering. I think that is like the only way to solve this in society is actually increasing the education of everyone. I'm not saying one part of the society, like everyone. That because whenever we have societies that they don't actually educate well everyone, like that, the ones that are vulnerable, because they don't have reference points where to actually detect these kind of things that might be like going off.
Right.
And I think I'm going a little bit off the topic. But...
Thank you. And you amplified again what I tried to get at beforehand. People are gullible, right? The fact that there's a truly synthesized reality out there, which we have a hard time to fake reality out there, which we have a hard time to distinguish from true reality. And you just need to go out to Hollywood, right? I mean, this is nothing new. The scale with which this is created these days is new, but it's not for the first time that there's been a fake image out there. Matter of fact, like, you know, that the first images that were created already had this fake notion to them. But leaving that aside, yes, I also believe that the data that you're presented with, the filtering process, is actually a much more critical part there, because it's much more subtle. And there's a lot of dual interest, as you said beforehand, in that process, targeting that. And it's hard to believe that the players who have it in hand, how much interest they have in doing that. And at the end of the day, I'm also having a hard time believing that people will love to be scholared into like what they're supposed to see. There's not too much difference between like a recommender system which helps you in your everyday processing of this huge amount of data, and almost like censorship or something like that. And yeah, we need to find out a way to tackle that. At the same time, media competency is needed. And we see that other competencies apparently are needed. Like children probably need to be taught more that there are different opinions out there, and that you just cannot punch the other in the face if you don't like what they believe. And every time a crisis hits us, like we see these days in the pandemic, the extremes seem to increase in both directions. And this has nothing to do with fake image generation or something like that. But I guess with that, we're getting to the core of the problems that we actually need to tackle.
Thank you very much. Mark.
Thank you for the interesting presentation. And so I'm a junior fellow in CUDAN myself, and I don't have a strong background in machine learning. I come from Semantic Humanities. So I understand that your goal was to enlighten the black box, so to say, but I wondered if I understood correctly, and if such machine learning modeling of different possibilities through synthesis, is it also a game changer for how a smaller quantity of data used to train an algorithm, and how this data can now basically count for actually a much larger quantity of data by taking into consideration the potential synthetic variations, so to say. So, for example, that if you think of, so I thought of it in the sense of artificial anticipation of future, and in let's say in self-driving cars, that this should mean that the recognition of objects, etc., should be a lot better. And how would you comment?
So, does interpretability help with transfer learning? That's probably the underlying question that you're asking there. And my group, we're doing quite a bit of work on transfer learning, especially from the aspect of metric learning, deep metric learning, that I haven't focused on in this presentation here. The goal of that is how can we learn from a bunch of data, visual data, for instance, what makes them similar and what makes them dissimilar. And metric learning has to it that you typically want to start on part of data and then generalize to other data, or even to data which comes from a different distribution, transfer learning aspect. And your question targets exactly the right direction. Does the interpretability actually help me with that? And my answer to that would be yes. I mean, that's the underlying promise there. Why? Because the interpretability helps you figuring out biases that your model might have learned, especially when data is scarce. And then you can afterwards not just look at the predictions that the model comes up with on additional test data, but you can go to a deeper understanding of what is the underlying concept of the data that it has learned. And with this concept, then figuring out if wrong concepts have been learned, if certain bias has, for instance, been learned from the data, to then get rid of that. And that's essentially where the interpretability goes to. If you map these things with the approach that I proposed here, and there's been other generative models for looking into neural networks that has been there beforehand, but the catch of what I presented here was that we were eventually trying to go for a bijective approach where the interpretable representation is equally potent as the original one. So you can continue in the interpretable space, so to speak. And if you figure out that wrong semantic concepts have been learned from your data, you want, for instance, to generate a model which is not biased to gender, if you want to use this for human resources, for instance. And if you figure out, no, I mean, the gender attribute here wins the day, yeah, then you know that you have a model, or the race attribute, then you know that your classifier at the end of the day would be racistic and not just go for qualification of the future employee. And these things help you, especially when you're having scarce data in place, to figure out if wrong biases have been learned. Yeah, to that extent, it helps with transferability.
Okay, thank you.
Interesting. So you said something which sort of before this question, but is also relevant here, which is regarding the recommender systems, right? That sort of make use of what we already know, right? Like it's a little bit like calling the 1980s radio station like Bayern 3 or SWR 1 where you're from, and you can select whatever music you want, but you're already in the audience of the radio show, so that means your world is the 6,000 songs that they have in rotation. And so basically you select from those, and then you basically add a weight to some existing song. And if you then build a recommender system based on that, plus some other information like the weather or the traffic situation, and then you do again recommending the same 6,000 songs, that's like censorship, as you say, because you miss out on the rest of possible music in essence. So that is on the one hand something that one can see as depressing, right? I mean, we all, anybody who uses YouTube for the last decade knows that YouTube right now is worse than it was due to like the strong recommender system approach in the background, right? So, but this actually raises and opens a possibility towards something extremely positive, because by seeing the limitations, of Facebook, by seeing the limitations of recommender systems, for example, we also at the same time find out what the possibility space is. We can actually say, okay, how these few things are distributed relative to what could be. We can also give people new opportunities. And the question is a little bit like in medicine, we're all different. So how feasible is it that instead of like, for example, having the one search engine for art history, the one narrative of art history, and the new and Gombrich version of like how the world came to be or whatever, we have possibilities for all of us. Like how can we make this something where every one of us can get out of their filter bubble? Is that something that you would subscribe to, A, and B, in the potential flower bouquet of applications and of methods and of data sets that we really want to have? Like, you know, when you figure out, oh, your Brazilian music is actually Brazilian music that was issued by people that are your age and lived in Vienna, plus some remixing with sort of beats that you are growing up with, but you don't have any idea about real Brazilian music and the manifoldness of that. Now you have realized that you can actually go to Brazil and say, give me all the manifoldness, without ending up in the same samba club. So in the same way, now that we have seen what has gone wrong with Facebook, now that we have seen what's going wrong with recommender systems in various platforms, what should we do now? And so do you have answers in your work for stuff like this?
First of all, to solve a problem, you need to be aware that there is a problem. Mm-hmm. And to solve a problem that affects an entire society, I believe you need to make the society aware that there's a problem. Luckily, things probably need to get worse before they get better. And these things, especially with recommender systems, already get so bad that the general society realized that there is a problem. So luckily that we can scratch from our list. At least a sizable fraction of our society has realized that with elections and so on, with policy building, with communication within our society, that there is an issue created by a recommender system. Without that, Facebook and the like would probably not have started, at least, to look into solutions. Not that they have found a solution, but at least it evidently needed quite some force to get them only to deliberate that there is a problem and what potential solutions could be. So that's the one thing. The second thing is, as I said beforehand, I doubt that you can force people to open their minds. We are talking about recommender systems, and that's a way of mindset that it influences. And for that is also required to change people's minds, essentially, because they will feel, if you give them different recommendations than what they prefer, that you start to nudge, if you do it subtle, or to force, if you do it less subtle, their opinion. And if you want them to accept what you're showing them, I guess you need to start a bit deeper. What I'm saying with that is, I mean, there's public television in a lot of companies, a lot of countries out there for exactly that person, that reason, to give each individual person hopefully less biased view on the world than they would have if they have chosen their sources of information in the first place. Nevertheless, lots of people here in Germany, living in big cities like Berlin, seem to be in very closed up bubbles, although they have easy access. It's not that like in medieval times or whatever else that people did not have access to these sources. I mean, that's the most puzzling thing that I find. Like everybody has mobile phone, internet in our societies is free as opposed to those countries out there where it's not, meaning like you can access each part on our globe. Each time, everything is accessible. And nevertheless, people start to close up even more. And I guess the only solution to that needs to come from the inside and not from the outside. You cannot force people to change their mindsets, at least after a certain age, that easily, or they will perceive it as such. And with that, I also doubt that they will readily accept it. And for that reason, I don't fully believe in solutions which I think these are, in the short run, it might here or there work. We can show them the fallout. I mean, like people have done after Nazi Germany collapsed, right? They showed people like what actually the implications of that will be, hoping that people will realize, oh no, I mean, this is where we're going. And I hope that a larger part of the still deliberately in filter bubble living part of our society, I hope we can reach them with that. If we point that, so you're asking about like ways to a solution, point out what will be the consequences of us going down that trench. But this is only the negative way, showing people like, if you do this, your mind will essentially be controlled by your filter bubble. I always hope that there's also a positive side to it. Let me with that switch gears there. There's those that prefer doing vacation only in one spot, those that prefer eating only, I don't know, one type of dish or whatever else, because that's their favorite dish. And nevertheless, if you look outside your window, the world is colorful. I mean, we have seasons, right? I mean, it's not that our planet is like IKEA, everything 90 degrees, everything in 1 or 3 different colors, right? And quite a few of us have over the years developed a palette to that, which in pandemic times, we find tricky that we cannot travel out and see different parts and so on. I mean, like we like this colorfulness. Maybe we can reach the part that only prefer black and white, their particular color, eventually showing them that out there's different things and that they will find it attractive, that they don't, and the last thing to it, I believe a lot of closing up also happens because people are afraid that there is another truth, another opinion out there, which they cannot battle down, which they cannot discuss down, which will eventually maybe change their mindset. Maybe they're even afraid of changing their mindset and lifting that. But this is something that can only start probably in early child age and helping people deal with different opinions, that the world is colorful, that there's different things out there, and cherish that for the reason that it's actually cherishable. So a positive take to that.
Nice, thank you very much. Anybody else? I also invite the people who have not been here before to ask questions. This thing we went into here is interesting. So we sort of started out with machine learning, very topical on method and stuff like that. We talked about the ethical dimensions and stuff like that. But now we're actually in an overlap situation where we're very close to home of, the Kulturwissenschaften, as they say in Germany, called cultural research science, humanities, art history, whatever. So there's one thing with images in art history, which is, in the long term, there is a struggle between like, should images be allowed because You know, it's not, there was a little island of photography where people believed that images are not painted, because even though this is not true even for photographs, right? But most images are sort of cheating and deceiving and are used as such. And so there have been times when images were forbidden in Muslim areas, in Protestant areas. And at the same time, they have been used at the same time to propagate the message, like Counter-Reformation is a good example, right? Il Gesù is full of images in order to convince the people that, like, you know, we got, the Protestants may have the better argument, but we got all the gold and the fancy stuff, so stay with us. And so we already see this thing that artificial intelligence is something that is hard to penetrate for a broader society to understand what it's actually doing, which itself may spark another form of xenophobia, as you just said, the xenophobia of like the unknown, like eating something I've never eaten, seeing a picture I've never seen, hearing a message I've never heard. In the same way, artificial intelligence is like that. Like it's sort of, in that sense, a part of science, which also has this quality. Now, the difference is that science is sort of supposedly rational, and artificial intelligence, due to this black box thing, is not, or is, let's say it's less graspable rational. And as a consequence, we have things emerging like artificial intelligence as a basis of religion, like the, you know, sort of like supreme intelligence that hasn't been built yet, already being instituted as a nonprofit religion in the US by one of the Uber founders, right? So the key thing is, how do we deal with that? Is that something that is part of the solution, or is it part of the problem? Do we see right now a kind of, do you see a kind of joining of forces of, you know, in the struggle between, say, a more rational worldview, common sense, and so on, and more fundamentalist, non-rational worldviews? Do you see that artificial intelligence is like pulled both ways in this respect? Will this be something where, you know, there's a decision to be made? So, or do you even fully believe, okay, like if people want to believe in that, why not? Like maybe there is a general artificial intelligence in 10 years who will tell us better what we should do than we would tell ourselves. So what's your position on that?
Question is if that's the last part that you mentioned, if that's actually what we want. If we want ourselves to be, negatively coined, dictated by such a general AI, which tells us where to go. At the same time, I would say this is probably the least adult approach to that. It's essentially believing that we are, as humans, so childish that we need somebody who's looking after us, hopefully something that we've then created ourselves, and that does it to our best interest, and not like in one of those dystopias figuring out, well, the biggest problem to this planet and to themselves is the human species. Let's just get rid of that and then solve the problem. So that would be the post-humanist or transhumanist approach to that, which I don't buy into, because we should do things here for the human species and not like beyond that, but that's probably getting a different trajectory. Do I see this thing getting better? I think it's going in waves. The humanist perspective would have been like in the 20th century, yeah, people gather knowledge, and with that, they're getting more and more clever, and intelligence is equated with wisdom, and with that, people eventually will learn to solve problems. Now we've learned that overall, people probably get more intelligent, but that there's a difference, a stark difference, stark contrast between intelligence and wisdom. People can be as intelligent as they are, and at the same time, they will not even learn how to eat or whatever else, and then die from that, malnutrition. And at the same time, people can know everything about the world, but lack the wisdom to deal with another, and societies can destabilize and so on. And I would say that we might overall, as a society and so on, probably have gained more and more access to information, and probably also gotten intelligent, but there's very profound skills in living, which is for me equated to wisdom. which are lacking in our societies, probably lacking even more than they were beforehand. See it coined on one simple part. Like, you might have thought that we are probably the most communicative and with that most skilled in communication society than ever existed. Now you have access to essentially every person on the globe, and to even more like thoughts from people that have already been died because the thoughts have been recorded. At the same time, you see our population being more and more isolated into smaller and smaller clusters, or even just living by themselves. And although they have the tools for communication in their head. So my point here being, intelligent, yes, but basic skills that we probably need, maybe here or there, they're even declining. But this should not be taken as full pessimism. The moment that we've recognized that there's a problem, I believe that we can also work on them as human beings and eventually find a solution to that again, if we so want. However, if we believe that this is not a problem, I doubt that we will get out of that. So probably the most important thing that we as scientists can do is show people that there is a problem and where this will eventually lead if we are traveling down this route, hoping then that bigger parts of our society, once upon realizing that there is an issue, will then want to tackle it in their own interest rather than being forced.
Nice. Okay. So we have 10 minutes left, and I would like to sway topics again to something that's way more profane, I guess, or maybe simple, but at the same time also interesting. So what we are doing here at Tallinn University with this CUDAN project is bringing together people from a very broad variety of disciplines under the moniker cultural data analytics. Like, we have a spectrum, like we sort of very consciously cover the spectrum all the way from cultural semiotics and history to sort of computational linguistics, computer science, and ideally natural science. And one of the interesting things is that basically, you know, if it wasn't for the pandemic, we would hang out in one lab space, and we do so nevertheless in occasions like this, where we work together on different projects. We share data, we share methods, obviously with different overlap, and we share space and also sort of interests. And so this is one end of the spectrum of how to do cultural analytics, obviously. The other form of cultural data analytics is to do it in a way where there is two more pronounced poles, where on the one hand, you have, like in your case, you have art history, and there's people who do a PhD or master in art history, where, you know, they're not even, you're basically any quantitative data visualization or course like that is not in the requirements. So basically they don't really need to know what you are doing. They get a PhD for interpreting the paintings, not for using whatever method you give them to do so. And vice versa. In the other part of the university, you get people who do a PhD or a master in computer science, who may do some project where you can plug in and out a sort of a painting data set, or, you know, a mammography data set, or, you know, whatever pictures you have of human cells, where then they do this thing. But so the question I have is, in your situation, how do you imagine, how do you guys architect the overlap? Like, what's the confusion matrix between these poles in the institution you just joined, which I assume you went through at least some co-conceptualization in this direction, because otherwise you wouldn't have moved there, right? And so how do you see the future of the field in that sense? Or is it really two fields?
So I see a lot of interest from both sides that you mentioned in the respective other field. And I've for long been director of an interdisciplinary center for computing. And they're also having different sciences, not just these two poles together, but I would sort of open this up to saying, like, there is even more out there, multiple poles out there, not just like natural sciences and humanities, but even in the natural sciences, as you know, there's multiple poles that you eventually want to bring together. Now, I believe that the scientific method has, over the last decades, created a lot of interesting approaches, and with that led to other disciplines having tools available which help them to generate new knowledge, essentially spur their scientific development. We've come to a point where the profound questions that we will now be facing cannot be faced purely alone. There's a lot of still questions in computer science which you can solve purely by means of computer science research, and humanities probably as well. But at the same time, there are profound questions which can only be tackled together. I guess that's what we're looking at these days. Humanities, on a very simple note, bringing up scalable problems for computer science, for instance, and computer science with the algorithms that we're having available, paving new avenues to accessing large-scale data that the humanities, other than that, would have had, or life sciences for that matter, would have had no chance to ever consider. And at the same time, when it comes down to the process that was partially also discussed beforehand, when it comes down to diving deep into the content of the particular data that we're looking at, I guess it needs both fields. Let's start with images. Computer vision, for instance, is all about computer-based image understanding. Who has the most profound expertise, scholar-wise, when it comes down to image understanding? Mm-hmm. Is it people that do image processing and the like, a discipline that has been around for shy of half a century? Or is it like people in the imaging sciences, for instance, art history and the like, who have done this much longer? If you look at how computer vision for long has tackled image understanding, tagging a noun to an image, for instance, and saying that this is already image understanding. I mean, everybody from humanities would have said, like, okay, this is where you're going, right? There's a long way to go. And the same the other way around. If you take the tools that are created by machine learning research and artificial intelligence these days, if you just take them as tools, something static that you can utilize, shovel data in, answers come out. I guess then you're falling into this trap of having an approach which you cannot interpret, cannot understand, you just need to trust what's popping out. For that reason, I believe that it needs to go either way, and researchers have to work together to then develop something new for the respective questions in the particular field or the intersection. Now, how large is this intersection? I believe that there's still research needed on machine learning, computer vision side, and for sure I will probably have enough work there to do till the end of my academic life. And I'm sure the same holds true for the other side as well. But I believe that this interface area is getting larger and larger. And if it's not already large enough, it's probably large enough for researchers to also spend their whole life on that already. But with entirely new approaches, computational approaches coming out essentially by the day, and Max, you pointed out, like most of that was just the last 2 years, and the amazing potential that is already opened up by these technologies. Just imagine what's coming there in the next couple of years. You can see that the intersection area is essentially getting larger and larger. When it comes down to content-based image understanding, and we're still just scratching the surface. And with better approaches there coming from the computational disciplines, I can only see that this interface area will get larger and larger, and it's already large.
Yes, yes. Thank you very much. This was a great answer. I do agree with you that the crowd is growing, which gives me hope, because so far there was a sort of inhibitor, right? Because like both in computer science, you couldn't do certain things because you were evaluated by pure computer scientists, and humanities, you couldn't do things because you were constantly evaluated by people who don't believe in quantification computation, for example, right? And now information science, network science are growing in ways where all of a sudden there's enough people to sort of mutually peer review each other in these areas, and whoever doesn't do it as a university, as a country, as a state, is losing out in essence, because they don't get a share of the cake of the possible stuff that one can do, I think. And so, you know, this is like sort of the final words. You know, as you have adopted the term, I think welcome to the club. This is something which we also carry some kind of responsibility, because everyone who carries this thing, Lev Manowitz is one, and there's different versions. Obviously, people call it cultural technology, they call it culturomics, and they call it all sorts of things. But there is something beyond digital humanities, which is, but at the same time, seen from the technological, computer science, and natural science discipline more than what they are doing. It's both in combination, and that needs to be grown as a group. And I think there's lots of communication necessary for people to understand that it's A, not just digital, B, not just tools for the humanities, and vice versa, not just, you know, like sort of solving your ethics question in a separate conference session, and so for the CS people. And so that is something which is very exciting to start. And all these things we have talked about today, they will probably, you know, reappear in the coming years, and it would be great to sort of stay in contact in that way from our side to you, and vice versa. And yeah, I thank you very much for these exciting and interesting 2 hours.